everyone, it's really good to see you here. So today we are going to solve a Leetcode problem which is rotating oranges. So what we have given is we have given a matrix of size m cross n, and where 0 represents an empty cell, 1 represents a fresh orange, and 2 represents a rotten orange. So what we can do is, like, every minute any fresh orange that is 4 directionally adjacent to a rotten orange become a rotten. Let's suppose if this is a rotten orange, then we have to check in all 4 directions. Whatever in the first second, whatever is adjacent to it, it become rotten, right? And again the further process applies to rest of all the oranges. So what we have to do is we have to find out the time taken so that all the oranges become rotten. That's not cool, right? But yeah, we have to find it out. And there may be also possibility that some are not able to, like, are not in the range of the given rotten orange. That's why it has not become rotten. So in that case, since all the oranges not become rotten, so we just return -1, because yeah, some fresh oranges are left, and that's a good thing, right? So this is the problem, and I hope you understand the problem statement. Now let's dive into its approach part. So what technique which we are going to use here is depth first search, and how we are going to use DFS here. So let's see. First thing which we have to note is that we have to do this thing. Whenever if we encounter 0, we just do not do anything. Whenever we have 1, we just increment the count. So let's count each and every one. So here we have 1 2 3 4 5 6. So now our count becomes 6. Initially it's 0. Now whenever we encounter 2 in our grid, what we do, we just increment its index into our queue. Why we are doing this? Because initially how many rotten oranges are there will be will be used further to make all the rest oranges rotten. And how it is going to be done? So let's suppose here in our current grid we have only one rotten orange, so in our queue we have 0 comma 0 as our index. Now what we do, we just run a loop till our queue is not empty, which is we normally do in our BFS. So while not queue empty, so if there is some value in the queue, we just run our DFS. Now what we do, we just make some temporary variable, which is the pair representing ij value of the rotten orange index. Now what we are going to do is we are going to check in all 4 directions of it. So again we are running a while loop till the point our queue is not empty, which means that after storing this, we just popped out this element, right? So we popped out this element. Now what we are going to do is we are going to again check. So here let's suppose we have 2. So for this 2 value, we firstly check in all 4 directions. So the 4 directions are this: j minus 1, which is downward direction, I plus 1 comma j is downward direction, I j plus 1 is rightward direction, I minus 1 j is upward direction, and I j minus 1 is leftward direction. So if there is some rotten orange here, let's suppose here we have 2, then all the oranges which are adjacent to it in this particular manner are going to be also rotten. So this is what we are doing. So you can see that here in this direction it is not possible, that's why we return from there. Here it's also not possible. Once we go in downward direction, you can see that there is 1. So once we encounter 1, firstly we just decrement the 1's count. Now it become 5, and then what we do, we just make it 2, so it become 2. And again if it become 2, then what we have to do is we have to just append its index in our queue. So now here it's 0 1, so this is 1 comma 0. So 1 comma 0 is pushed into our queue. Again you can see for this element it is going to again for this element you can see that here it's also 1. So what we do, we firstly make it 2, we just decrement the count of C, which now become 4, and then what we do, we just call, we just again, okay, so once we are done with this, you can see that now you have to append this. So this is 0 comma 1, right? And again we have to check in our queue. So since our queue is not empty because we have these two elements, let me change this to green. Okay, so now we have these two elements. So what we do, we firstly go here. So we firstly go here and check in all directions. So you can see that this is not possible, this is not possible, this is also not possible, but this is possible, right? So just make it 2, and then what just do, just add, just decrement this count. Now it become 3, and then what we do, append this index in our queue. So now we have 1 comma 1 here, right? And this is popped out because we had used it. Now what we do, once we are done with this, we are going to use this. So for this particular 2, we have to check in all 4 direction, right? So here you can see that for this direction it is going to only have 1. So we just make it 2, decrement the count, which is going to be 2 now, and then what we are going to do is just append its index. So this is 0 1 2, so this is 0 comma 2. Now you can see that this is exhausted. Now you are going to use this. So at 1 comma 1 we have this 2, right? So again we are going to make a check in all the 4 directions, right? So you can see that here it's only possibility is this. So we just make it 2, decrement the count, and again add this index. So this is 1 and this is 2. So this is 2 comma 1. So this is appended in our queue. Now this is exhausted. Now what we do, we just come here. So 0 comma 2, which is this 2, and you check in each direction. So you don't find any value which is possible. So that's why this is also exhausted. Now we are left with this 2 only. So what we do, we just go in all 4 directions. So let's use blue. So this direction is not possible, this is also not possible, this is not possible, but this is possible. So just make it 2, decrement count. So now it becomes 0, and what and just append this here. So this is 2 comma 2, right? So this is exhausted now, and then again call for 2 comma 2. So you can see that there is no other possibility for that, and so that's why this is also exhausted from the queue. So you can see that once our C value becomes 0, that means whatever the fresh orange present inside our grid is now become 0. That means all of them become rotten. It is means that we are able to exhaust all the rotten oranges. So now the time taken to do all this would be counted as how many times we are going inside our DFS function. So okay, let's see this in the code. So what we are doing is we are going to use C, which is initially 0, and N and M are row and column size. Now there is a queue which is of pair and pair int comma int. So what we are firstly doing is, as I told you that if grid is equals to 2, we just have to append or push it inside our queue, and if grid is equals to 1, we have to just have the count, like how many total number of fresh orange are present inside our grid. Now in answer, this is going to return our required value. So what we are doing is we are running a while loop. That is an obvious thing for BFS function, right? So what we are doing is S is the size of the queue, and if C becomes 0, that means we have to return our answer. And C equals 0 represents that all the oranges are now become rotten. So while our S is greater than 0, that is the size of the queue is greater than 0, we have to run this particular functions. And end of it, you can see that we are appending our answer. So in this, what we are doing is we are just checking in all the 4 directions. So you can see that temp is representing the front of the queue, and then we are popping it out. Now I and j are the first and second element. We are checking, like this is to check like if I greater than 0 is possible, then what we do, we just go in the, you can see that we can now go in this upward direction because this is possible. So we check that if upward direction is equals to 1, then we decrement the C count, and then we make it 2 and push back the index of that particular grid element where it is equals to 1 in our queue, right? And again, if j greater than 0, we do the same thing. So j greater than 0, that means we can go in this leftward direction. And if uh, I is less than, you can see that here, if I is less than n minus 1, that means we can go in downward direction. And if j is less than m minus 1, then we can go in this rightward direction, right? So after doing all this check, we are able to find out how many elements are going to be written at that particular, for that particular orange, right? So end of this, we are incrementing our answer vector. So answer count, sorry. So yeah. So after coming this while loop, so this while loop, what it does, it just make all the 4 direction adjacent element where grid value is equals to 1 as 2, and then additionally it just decrement the fresh orange count, and also pushes the index of each element in our queue. So the number of time we have to do this to check this all 4 direction, what we have to do is we have to just increment our answer vector that particular time, answer integer, right? So end of it, we have to just simply check that if our c value is equals to 0, that means all the fresh orange are now exhausted, so we return our answer. Otherwise we just return -1, because if any one orange is also left fresh, then we simply have to return -1, because it is impossible to make all the fresh oranges as rotten oranges, right? So let's try to submit this up. So yeah, this is the solution to solve the problem rotting oranges. And if you want to access the code, then you can check the GitHub link given in the description. And before going anywhere, do like, share and subscribe to this channel, and thanks for watching.